We'll wrap term 3 up looking at Pythagoras' theorem and trigonometric ratios and apply them to a number of different circumstances, both familiar to you and somewhat unfamiliar to you. So what we've got with trigonometry are 3 particular ratios: the sine ratio, sin, that's what I always saw those buttons on the calculator, sin, cos, and tan when I was a kid and wondered what they were. So they're the trig ratios: sine, cosine, and tangent. And recall that the sine of an angle theta is the opposite over the hypotenuse. So it's that ratio, the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent, which leads you really to this particular, I don't know, what is it, acronym, to remember the ratios. Okay, and so for a lot of people who haven't revisited high school mathematics in their adult life, this is pretty much all they'll remember. Like a lot of parents go, oh yeah, that SOHCAHTOA thing. So yeah, that's what we're doing, that SOHCAHTOA thing. Right, so we can use our calculator to do a lot of these things, both the trig ratios and the inverse situations. So let's get stuck into some examples and see how they go. Solve the unknown in the following. So what we've been given is an angle, a side length, which is the hypotenuse, and we're trying to find one of these smaller unknown sides. So the aim of the game is to identify which trig ratio we're going to use. Now this is the opposite side, so it's opposite the angle, and we've got the hypotenuse. So we're going O and H. So SOHCAHTOA, and it's the opposite and the hypotenuse that we're after. So this one here, we're going to use sine. So the way I'll do it is I'll write out sine of 25 equals the opposite, which is D, over the hypotenuse, which is 77. All right, so I need to solve for D. So what I'm going to do is say that D equals, so I'm going to times both sides by 77. All right, and that will be D equals 77 times the sine of 25. Okay, D equals. Now what I do is I reach for my calculator. Now, at this stage, probably think of an appropriate value for D. Like D probably looks like it's going to be about 20 odd. If that's an angle of 25 degrees, that's 77. I reckon 25 would be probably a common sense answer. All right, so let's see what the calculator says. So trig can be accessed from the trig menu. And what we're going to do is say 77 multiplied by the sine of 25. Now, the other place you can find the trig function, so if you type in 77 and then multiply, you hit Shift and 1 and it will insert sine straight away. So that's a handy little feature there, 25. I think 25, 30, maybe 15 might be an appropriate answer. I'm going to hit enter on this and see what happens. All right, so negative 10 is obviously not an answer that's appropriate. Now, what's happened here? So the first thing to note is when you're using the calculator, it needs to know which mode you're in, and it needs to be in degrees mode if the sine, this number here, 25, is in fact in degrees. We use another measurement soon, we'll show you, called radians, which is the mode I'm in here, radians. Okay, we use that one for 11 methods, 12 methods, and the next part of the trig topic in year 10. So we want to be in degrees mode, and let's propose this, and it says 32, which is a hell of a lot more appropriate. So we're going to say that the answer is 32.541. I'm just going to say ... because there's nowhere in here that says rounded to 2 decimal places or 3 decimal places. So I'm implying that this continues. There's no unit of measurement, so it's D units. All right, let's do this next problem here. So what we've got is an angle. We've got this side here, which is a shorter side, and this side here, which is a shorter side. So we'll call this one the opposite, and this one here the adjacent. So this is going to involve O and A, and that's the tan ratio. So let's write out what we know, which is tan is equal to, or the tan of 58 is equal to the opposite, which is 24.61 over the adjacent, which is G. All right, so now what I need to do is get G out of the denominator. So what I'll do is multiply both sides by G and by G. So I'm left with G tan 58 equals 24.61. Now what I need to do is get g by itself, so I'm going to divide by tan of 58. Now many of you who are familiar with trig will just make that swap straight away, which is absolutely fine. They cancel out. And I need to work out what 24.61 over the tan of 58 is. So I'm going to do that. So 24.61 divided by the tan, which is shift 3 of 58. Now again, it's a really good idea to think about what it might be. So 58, I don't know, like I reckon that an appropriate answer might be like 20 maybe. Goes up into 58 degrees, going up faster. So I reckon about 20 might be an appropriate answer. 15.3 seems good enough to me. So 15.378 dot dot dot, and it's units because there's no units in there. All right, well, this particular point, what we've got is we don't know what this angle is here, but we know this and this length here. So what have we been given? That is opposite the angle, and this is adjacent to the angle. So what trig ratio covers those two scenarios? It's going to be tan again. The tan of theta equals the opposite, which is 0.61, over the adjacent, which is 2.35. All right, what's it going to be? How do I work this out? I need to get theta by itself, and I've got this tan sitting here. The way we do it basically is we multiply both sides by the inverse. Ugh. 2.35. Okay, and what that inverse does here is it basically just chops out that tan multiplied by its inverse, leaving us with theta by itself, which is fantastic. So all we need to do at this point, girls, is just type in tan inverse and find the inverse of this particular trig ratio here, which gives us the angle. It's sort of like working backwards, basically. All right, so tan inverse 0.61 over 2.35. And again, it's a good idea to just have a bit of a guess to see what you think the angle might be. So notice it doesn't go up much compared to how long it is. So the rise is not that much given. It runs 2.35. So I'm guessing it's going to be a fairly low angle. I'm going to take a punt and go 10 degrees. All right, so 14 degrees. I was a bit wrong, but not too bad. At least I didn't guess 85 degrees or something. Okay, so it's 14.551 dot 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 because there's no suggested rounding, and we're going to say that that is degrees because we're in degrees here. All right, so there's your set work. It's mainly revision from last year, but there's a few curly ones thrown in for good measure. Good luck with that.